Good afternoon. Welcome to the afternoon session of Best Plans Review with Lockheed Martin Missiles and Fire Control Orlando. At this time, just one housekeeping issue. Please turn off your cell phones. The sponsor of this tract is Infor. They couldn't make it to do this introduction. During this session, my name is David Drickhamer. I'm editor-at-large for IndustryWeek, and I will be moderating this session. It is going to be a little bit different format than a lot of the presentations. We're going to do a brief introduction of the facility and what they do, and then we're going to do a Q&A, and we're going to turn a lot of that over to you. So as questions occur to you, either jot them down or raise your hand, and we'll answer questions. And the purpose of this structure is so that you can get your questions answered. It's often said that at a conference like this, if you find one good idea that you can take back home and implement either next week or tomorrow or next week, then the cost of you attending has been paid for. So I hope you get that idea in this session today. With us today from Lockheed Martin's Missiles and Fire Control is Mel Schubert, who has more than 30 years of production operations and leadership experience. Mel is currently the Fire Control Factory Senior Manager. He is directly responsible for the production of the Arrowhead TADS, the Sniper Advanced Targeting Pod, and the GMS-2. He has been the driving force behind the manufacturing success of the Sniper ATP program and reducing costs to make it an affordable option. In addition, Mel has accomplished a 100% on-time delivery schedule while almost doubling production and decreasing hours per unit on every program. He is currently responsible for production operations that includes 240 employees. Without further ado, here's Mel, and he'll introduce Matt as well.
Good afternoon. What a great speech that Lee gave, and here I am trying to follow that up. So that's going to be a really hard act to follow. Why don't you, if you don't mind, come a little closer here? It's going to be more of a conversation, and I feel like it's church. No one wants to sit in the front row, and I think it'll be a little bit better for everybody. We get to know each other. Matt McCloud is one of the important people here because he really put the first part of our application together. Matt is one of our OLDPs, and what that means is the Operations Leadership Development Program, and he's one of these early career folks that we do 4 separate rotations with to really get to know the whole business. One of those rotations was working for me in the Fire Control Factory on a special projects assignment, and he put the application that got us to be nominated and then selected as a best plant this year. And it was actually our second time through, because the previous year we had accomplished the nomination and were down selected to the top 25 but didn't make the top 10 cut. So Matt is going to help me through this. He's very knowledgeable on a lot of the data that's in here. I'm going to give you just a very short overview of Lockheed Martin and then kind of narrow down into my part of a very big company. And so I don't want to do a lot of these slides because it'll get a little boring, and I think we'll have a better conversation. We go to questions. Almost $40 billion in sales, 140,000 employees. 3 years ago, we were at 130,000 employees, and that's because of growth, not acquisitions. So the company is getting bigger and bigger. The portion of the business that I work in is electronic systems, and there are 4 different business areas: aeronautics, which we manufacture the Joint Strike Fighter, all the aircraft, F-16 and the F-22 Raptor, space systems, the rockets and satellites, and global information systems, which is a lot of that effort is with Homeland Security. In electronic systems, we'll make the division that we're particularly in is Missiles and Fire Control. And Missiles and Fire Control have locations all over the United States, as you see here. And Matt and I are located in our Orlando office. And our other divisions, I guess the two large divisions are the hubs, are Orlando and Dallas. It was part of a consolidation effort, or not consolidation, a consolidation of the whole business, but a merger that happened in 1996 where we became Lockheed Martin. Some of our competencies in missiles and fire control, hit-to-kill technologies with systems like our Patriot anti-missile capable system, which is the PAC-3, we call it PAC-3. And I don't know where I'm doing. I think it's me. The new systems that allow hit-to-kill technologies, and these are technologies that will allow a missile to hit another missile at very, very high speeds, hypervelocity speeds, and basically by hitting it, destroy it, and destroy it at some pretty impressive ranges. Tactical missiles, kinetic energy weapons, and fire-and-forget weapons like the Jazzy system, and fire control, and that's where Matt and I fall in. Fire control's electronic systems, and the systems we manufacture today are the system that goes on the front of the Apache that allows the pilot to see a target at the outside envelope of its weapons. So if those weapons could go X number of miles, we can see that far and beyond, day or night, and the image is high definition. If you think of HD TV, think of that kind of image on the heads-up display that the pilot can see. And today, the warfighter has to fight not in a battlefield where it's in the middle of the desert and there's tanks on one side and good guys on one side and bad guys on the other. It's a Datsun pickup truck in the middle of the city, and the bad guy has a RPG in the back, and you'll have to be able to find the bad guy and to identify the target and to execute that target at ranges so that the good guys, our people, are far enough away that they're not going to get into it. And the Arrowhead system allows them to do that. See the target, they designate the target with a laser. The reflected laser energy comes off of that target and is picked up by laser-guided munition like a Hellfire laser-guided missile. And when the missile is fired, wherever that laser spot is where the missile will hit, very, very accurately. And we build that for the Apache. We build the fixed-wing targeting systems for the F-15, the F-16, the A-10, the AV-8B, the Harrier, a whole series of fixed-wing high-performance aircraft, and that's called Sniper. And that system is the system that right now all the Air Forces want, because it can see targets many, many times what our competition can. And we have a real hard time getting into that market because of price. And we've worked very, very hard in what we do in our value stream to really reduce the cost so that we can then become price competitive in the market. And once we have, because our product performs better than the rest, then we're really now dominating the market. As far as the overall organization is concerned, in Orlando we've got 5 different manufacturing centers, a EPL, engineering prototype lab, microelectronics that build microelectronic sensors, laser spot trackers and that type of thing, which are hybrids. Precision machining are precision optics that make multispectral optics. And then the final assembly and test area that we do in the fire control factory, which I'm responsible for. And within that value stream, we have 435 operators. All of them are UAW. We've got about another 400 support people, MEs, QEs, IEs, production control facilities, supervisors that make up the management teams. And the teams are broken down into, we'll talk a little bit later about this, but performance management teams where each group is challenged with its own set of metrics, and those metrics really allow them to act as individual companies within the company. I think the journey that we've had over the last 20 years, and specifically the last 8 or 9 years, have been really integrating lean across the entire enterprise. And when I say that, from the top guy in the company all the way to the lowest person, we speak a common language of lean. Everyone's been at least at 1 or 2 Kaizen events a year. The top guy, if you ask him about value stream and value-added, non-value-added, and Kaizen events, and he understands all that, understands what the tools can do. You ask the first-line operator who's been in the plant 3 months, they understand it because they get trained in it. And because we have this common language, it's really helped us down this continuous improvement path. And I have a whole series of other charts there. I'm going to not show them. There's one little video clip that I'd like to show a little later, but I think we're probably better off doing some questions and answers.
Just wanted to start off just ask you, what does lean look like? And maybe you start from a description of the complexity of your products, and then step back into how you are set up to make those products from a lean perspective.
The value stream is so that we've got, let's just say there's make and buy. Everyone has those kinds of issues, right? What do we make? What do we buy? Our philosophy is if anyone can make it, then let someone else make it. We want to then focus on the things that segregate our products in the marketplace, which is where the make part of our value stream is. The products are complex in terms of a typical fire control system might have 25,000 parts in it, and we're fairly low production rate. The Arrowhead system right now is our highest production system, and we're delivering it 1 system a day, about 20 systems a month. Multiple programs at our site. We probably have 100 different programs. Some are very low rate. Some are in the different phases. Phases of the program, development phases, independent research and development, what we call SDD, system design and development, LREP, low rate initial production, full rate production and supportability. And then beyond that, you could have a PQDI, a pre-planned product improvement program, where as technology changes, then those are folded back into products that are then improved and help the customer to be able to use these emerging technologies to be a force multiplier. You've heard the commercials, an army of one. What you want our customers, the Army, the Air Force, we want to have these emerging technologies to really help them be successful in their defining moments. And we listen to that customer very, very intently. It's not like, here is what we have, what do you want to buy? What we ask the question is, how can we help you be successful in your defining moments? And really listen intently, because that's really where the emerging technologies are applied in systems that help them.
But how is the lean?
Lean.
Yeah. So with that.
I think that lean has helped manufacturing become a strategic asset. If you think back a number of years before I was commenting just at the previous speakers that were in here, I said how sophisticated manufacturing has come and how educated the folks are in terms of how we're applying these lean principles, and how lean has really helped us go from those guys out back who manufacturing stuff to an organization that really provides a strategic advantage in the marketplace. And lean, by doing that, what I mean by that, being able to reduce our costs so that we can control price in the marketplace, we have an ability to work price in the marketplace, but also to be able to get product to the market more quickly. So we recognize that lean, like about 8 or 9 years ago, was going to be a very, very important part of our overall growth strategy, and we invested in it pretty heavily. We have a corporate level guy, a fellow named Mike Joyce, who is responsible for lean and how it goes through the entire organization. And we've got, as far as missiles and fire control, we have over 1,000 certified green belts. We have 150 or so black belts deployed across the organization. And lean really is about the way we do work every day. And it's become like getting up and brushing your teeth. It's today we are thinking about how we are able to reduce our costs. Each of those PMTs, and we just mentioned the PMTs, they're responsible for an excellence plan. That excellence plan identifies what events that they're going to hold every week, every month for the entire year, so that they end up have a roadmap at, I'll call it, bottom line level. These are teams that are 20 to 25 people in size, and they've got costs, quality, schedule metrics, and the lean part of that is in their excellence plan. And their excellence plan is then developed so that they'll meet those goals and objectives. And we'll talk a little bit later as we get further on as far as how that whole performance management team works, because it's a kind of the anchor in which we execute lean within the organization.
And I would also say that lean is something that is not just in, Mel talked about all the green belts and black belts we have. We filtered a lot of the lean toolkits to everyone in the organization. So even if you haven't gone to green belt training, every operator on our floor knows what a shadow box is. They know what we call 6S instead of 5S. We had safety on there. They know what that is. They've participated in some sort of improvement process. They know what process mapping is. They've witnessed the sticky notes on the board and trying to figure out where the waste is. Everyone from the top of the organization on down has participated in that at one point or another. And so that common toolkit and common language is out with everybody. And we're now even filtering it back to our suppliers. With supplier, we call them supplier PMTs and different functions like that, where we go out and work with our suppliers and build a better partnership with them and try and bring some of the lessons learned we've gotten out of lean and help them with their business so they can in turn help us.
And the way you're rolling this out in a lot of ways, are these events using the events to apply the tools to improve specific processes? Is that right?
Yeah, to improve our processes and our products.
Okay, very good. Okay, I just want to remind everybody, feel free to ask questions if you have any questions as we go along. I can ask questions all day long. That's what I get paid for. So, as they come up, go ahead. Questions?
Okay, open questions?
Yeah, absolutely. That's...
So, during your journey, have there been metrics? Of course, we're kind of all metric driven.
Yeah.
Are the metrics that you decided those were not worthy of pursuing and adopted others? We're kind of going through all this together at different times.
Yeah.
Some metrics are really business drivers, and others that you discarded. Can you talk to any of those that you might have said, that really wasn't value added, we moved down to this?
The performance management team is a group that we end up, kind of a central group that every year the leaders of the PMTs end up interfacing with this kind of central group that says, okay, what are the metrics that we're going to measure? And so we have an opportunity to change them on a year-to-year basis. But I think one of the biggest things that we've seen in Fire Control Factory is we used to do just performance to standard. And, we used MTM standards, out of the 1,000 units. Each step had a known set number of minutes or seconds that we were then going to compare the actual to give a performance. And then what would happen is it would get summed up in a system that we could tell by operator or by work cell what the performance was. And we still do that, but we've gone and evolved to hours per unit. And this is, what we would do here is it would kind of miss some non-standard rework that would always occur, and you could have pretty good performance to standard, but you'd miss this over here. So we've gone to hours per unit. Hours per unit is, it's it's everything in there. It's touch, it's support, it is all the hours, and we segregate it by hours per unit that's on standard and hours per unit that may be non-standard work. Work that means, if something's gone in the test has failed, and we bring it back and we'll have to rework it, right? And the product that we make is, everything is tested. It's tested to a very high level of stress. And why that's important to us is it's mission critical hardware, and I don't do sampling. I don't say, okay, because this past 10 passed test, I'm not gonna test the next one. Every line replaceable unit, every sub-assembly, every top-level assembly gets very stringent tests. So when we get a failure, it'll go back and it's non-standard. But it's still included in the cost. And the cost then, in fact, on one program, we roll all the cost up so that we'll know on a weekly basis what that pod cost us. And it's an important metric that has really helped us drive not just touch cost, but then support cost. The support cost is often where you have a lot of money anyway. So that's one major metric. We've gone away from, and maybe we need to go back to this, is cycle time. I think that one of the other speakers talked about it this morning, that cycle time is very important. We've probably gone away from that, and we're really just focusing on on-time delivery, and the team's doing great. I mean, we'll move heaven and earth before we'll miss a delivery, and the result is the team's happy. They're very focused on it. I don't have to push very hard to get them to deliver that. Part of that is because, I'll say, the patriotism of the team. And we've got, in fact, just a little story. Yesterday in the factory, there's a little lady. It could be anyone's grandmother here. Her name's Linda Carter. And Linda Carter's son, John, was Special Forces, and he was Special Forces in the Air Force and got out and decided, I need to get back in. So he went back in for another 10 years, this time Special Forces in the Navy. So he spent 20 years in the service and is retired, but he's still in the reserves. Well, his son, Linda's grandson, is now in Special Forces. His name is Brian. And yesterday, Brian came home from the Creek. And this is a great story because the team got the address. These addresses, the soldiers are kept pretty quiet, right? The parents know it, but no. So Linda says, here's the address, and the team wanted to give them care packages for Christmas. So, being a young kid, he's 18 years old, right? He gets 150 care packages for himself and then his whole platoon. So he's like the most popular guy in the whole platoon. So he's come back and he's on leave. So he wants to come and say thanks to the team. So he came back in yesterday with his dad. So here's Linda with her son and the grandson. They're in the factory, and people that are building the Arrowhead system that are protecting these folks, right, are there. So the idea of making the product perfect and then testing it to the point where we know when you push the button, it's going to work the first time, every time, is part of what we do. And it's part of how people pay attention to delivering things on time, because the product doesn't sit on the shelf. When it's delivered, a week later, it's overseas. So it's important. And those kinds of things connecting us to that customer. One of the things, I think on the first slide, it said the Lockheed Martin, I don't know if it's a motto or a trademark, it says, we never forget who we're working for. And for us, it's easy because it's family. And
Matt, you wanted to add something?
I was just going to go back on another thing that metrics, and Mel talked about the PMT system. When you're on a team, like I was for a couple of years before I got into the program, and now, beginning of the year, you get a chance to make your own goals, and you influence your own metrics. That's kind of nice, and every year it adjusts. And we found along the way that certain metrics are really applicable at a higher level, but not so applicable on the floor. The best example I could give is I was on the test team, and while non-conformances that are over 10 days old is a great metric for the program to see how you're doing on fixing your problems and getting things taken care of. For a team level, the test team was getting hit every month for having too many non-conformances. They're not building any of the parts, they're just the ones testing them. So of course they have all the defects show is there. So kind of moved away from things like that to focus more on, okay, what is the test team doing to fix these problems, and how quickly are they identifying errors, and how good are they at preventing them in the first round of tests before we get later on in the process and it gets more expensive. So it's iterative. Every year we work on the metrics, and there's always going to, every operator is held to these after we make the agreement at the beginning of the year. So there's always time throughout the year, and you kind of go through, okay, maybe that worked, maybe it didn't, and then every year we reevaluate and try and make them more applicable to what we do.
And the testing protocol is pretty rigorous, right?
Mm-hmm. Mel touched on that briefly. Basically, we do just about everything we can to break it. If it works when it's in our facility, it's going to work when it goes out there. We do extreme temperature testing, vibration testing to try and simulate beyond what that part is going to experience on the front of a helicopter or under the wing of a jet. And so every single part gets tested completely 100% electronically. Then it goes into this environmental testing, and then it gets tested 100% again. And sometimes that happens at a component level and then again at an all-up assembly level. And that's just because we cannot afford for one of those to get out there and have one bad solder joint or one defective component.
Any other questions right now? As far as maintaining, obviously Lockheed Martin has been doing Lean specifically for a number of years, but before that there was a culture of excellence. How do you maintain your focus and that attention to quality, etc., over a long time frame? And obviously the knowing the customer is part of that, but actually the day-to-day level in the assembly process and all that. How do you do that?
We'll talk about CAP. Corrective Action Board.
Okay. One of the things that we do is we have different organizations, different groups looking at each level of the program, focusing on quality issues and driving those. So it starts at each level and gets driven on down. To kind of keep that focus, the teams that we're on, you have the metrics that are kind of an incentive. You get the rewarded if you achieve your metrics. Mel already touched on, the closeness with the people that we're working for. There are posters up all over our plant that show a picture of, this is Sergeant John Smith, brother of MFC Orlando employee, Jim Smith. And we kind of keep that focus. We bring them in for a lot of visits. And also, too, I would say that when I joined the company, I had a couple of choices on where I wanted to go. And missiles and fire control was already such a well-run and already had a level of excellence, so that's appealing. So I would say that excellence a lot of times breeds additional excellence because people are drawn to that and they want to continue to keep those high levels of quality. I mean, you'll hear programs that have different mottos about how we do not miss delivery, or we don't let things get out, and a lot of people take pride in that, and personally, I think it just kind of helps continue and keep the ball rolling.
The other thing, every failure that we have, whether it's in the factory or in the field, goes into a corrective action database. And we go through a formal corrective action process that goes through an analysis that gets us the root cause and corrective action. And that's built into our day-to-day process. And a combination of performance management teams, and maybe I should expand a little bit more on that. I told you about, they're broken down, each one has metrics. The teams are led by first line supervisor. Those supervisors are, every year they negotiate what the goals are going to be depending on what's happening that year. Example would be if they're a brand new program that's just being introduced, their goals may be different than they were the previous year as they were on a very mature program. So it would be different from year to year. But then the teams are ranked based on their performance. There's scores that they get for cost, quality, schedule, and there's a whole series of within those cost, quality, and schedule metrics that they measure. They get rewarded points, and those points then have the teams rated. They're rated platinum, gold, silver, bronze, and management focus. And of course, you don't want to be management focused. The system we put in place then generates the charts that represent that. The teams come off the floor on a weekly basis to a PMT meeting where the teams go over the metrics. They are a way of really driving change because they look at them, they analyze why a metric is not being met or why a metric is being more than met, and then they'll take action. If it's a metric, if they're exceeding a metric, they'll take a challenge to the goal. And I'll explain a little later why that's important. And if they're not being met, they'll put a corrective action plan in place that will help them get there. And then at the end of the month, they are rated platinum, gold, silver, bronze, etc. And then they're recognized each month for those platinum teams because we have PMT of the month breakfast where the whole team will come up, and it's usually 8 or 9, 10 teams that will come up because they're ranked platinum of about 40 teams or so in Orlando, and the team lead or the designee will come up, and the top groups of the management team, the directors and VPs are there, and they get a chance to say, hey, this is what we did to make our ranking. And then on a quarterly basis, they're rewarded. We have a program where, depending on how their quarterly rating is, they get rewarded with a gift card. The gift card goes to everybody within that team, and it's an equal amount. Whether you're a production operator, you're the supervisor, you're the quality engineer, it's all the same. So the team is certainly incentivized to drive continuous improvement. The corrective action board then works with the team to drive root cause and corrective action so that we always look at continual improvement. And then once it's in the field, we look at mean time between failure so that when the product's out there, we have a predicted failure rate based on the number of hours that's being used. And we pay very close attention to that. And if we get any dip in that, we understand what that is and roll that back into both the program team and the ops team, which then drives more corrective action. So it's kind of a loop system, a feedback system that continually drives quality improvement.
You mentioned the incentives for one individual team that's got the bronze, silver, and gold, etc. Is there an incentive for one other team to help another team so there's overall success versus individual team success?
Each of the teams then roll up to a senior team. So the senior team, like my staff, is a senior team, and they look at all the teams. So the team that may be struggling, right? I have a group of guys and gals who are the Delta team, and we look at all of the metrics, and when someone's struggling a little bit, I'll put the subject matter experts in. And Delta Force is like the Army Delta Force. They go in, do a mission, and get out. So they go in, help the team, train the team where they're not meeting what they need to do, and once they get set, they get out and allow the team to be successful.
Also, if you're doing some sort of cost-saving enterprise, you're trying to improve a process, if you work with another team on that, our system is set up so that you split the benefits, you split the savings between the teams that have worked on that. And it doesn't take long for each team to realize that it'll work a lot better if we work with this team over here. We can get a much larger number than we can on our own. So there's a lot of inter-cooperation.
And if one team finds a new product or process, then it is distributed across the teams and shared across the teams. It's one large facility. And there'll be a video a little bit later about, you'll get a chance to take a look at it.
Well, let's We'll take one more question, and let's get to that. Go ahead.
Earlier, you mentioned rework. Does that justify to stuff freshly coming from the factory, or do you get repairable parts from the customer?
We get field returns, and they're handled on what we call a depot repair form, and they're handled a little differently because it could be that they were out there 10 years, and they come back with bullet holes in it. It's not because of a failure, it's because of, and they'll come back for repair. So we evaluate it, we'll test it if we can test it, understand what the failure modes are, and then go through this, that we do a failure analysis board. The design engineer, the quality engineer, the field engineer, manufacturing guy all get around it, and they see what the field data is, write up the instructions that are required to do additional testing and rework, and work it through there.
Do you have a systematic, do you have a database or a way of capturing and tracking a failure code?
Yes, we have within our system what we call FACS. We've got different failure codes within the first manufacturing process, and then once it comes back into the field, there's a whole set of other codes that we do. So we can then select the data, dice it, slice it and dice it any way that we need to.
All right, with such a low volume production and high complexity, obviously you have to maintain some flexibility in what you do. Talk a little bit about some of the ways that you do that maintain that flexibility and execute. I think you can show the video right now.
One of the things that we did 8 or 9 years ago, we realized that the business is going to change, and the business and the business changed in a way that said two things: that the shelf life of technology keeps getting shorter, and the available dollars from our customer are going to be less and less. And we had programs in the past, literally, where someone could graduate from college, get on that program, and retire from that program when they're 60 years old. And those programs are long gone. Typical program today can last anywhere from 6 months to a couple of years, and then within that couple of years, there are probably 3 or 4 technology insertions within that, constantly changing. We realized this was coming, and the old models in assembly and test anyway were such that each area, each program, had its own little fiefdom, had its own little final assembly and test area, and they built walls around it, put cipher locks on the doors, and had secret handshakes, and something was happening good over here, they wouldn't share it with this team, and I have too many people over here and not enough here, they wouldn't talk to each other. And we realized that wasn't going to work. So we benchmarked all over the country, and we went to a company out in Austin, Texas, that you guys all know, that we really thought was doing the right thing. They were embracing this shelf life of technology issue and using it as a competitive advantage, and that was Dell Computer. Every couple of weeks they were coming out with a new computer during those days, and we said, how are you doing it? How are you really leveraging this as a competitive advantage? And we went out there and we saw flexible manufacturing cells that were set up so that they were doing a specific job today. And in 2 weeks, they were going to do a different job. And they were reconfigurable. All the utilities out there came from the ceiling, and it kind of looked like a whole bunch of spaghetti coming down, the utilities with their power and data lines and phone lines and all that. We didn't like that part, but we liked the flexibility. So we did our own benchmark. After we did the benchmarking, we did one area where we did a Pathfinder. We bought some of this equipment, flexible equipment, and we ended up with Production Basics, which is a company that will provide these work cells, reconfigurable work cells, and it's kind of like the erector set. You can build them up in any configuration that you need to. And after we worked with that for about a half a year, we then went on a fairly large capital investment program. We spent a lot of money refurbishing this space. This is a space of about 100,000 square foot. all for electro-optic assembly and test. And the area is set up so that it can be reconfigured very, very quickly. And what I mean by that, the example I use is we've got a U.S. Army customer, and he called us one evening and said, the op tempo in Iraq's gone through the roof, we need you to double production. And the old model would say, well, you got, the FAR, the Federal Acquisition Regulation, says that you can charge us for all this non-recurring cost. And the old model would say, you get a contractor in there, and you get a bid, and you evaluate the bid, and they come in and they tear apart the whole place because everything was bolted to the floor, and all the power was hardwired. And $1 million later, in 6 months, you could get the place reconfigured and you double the production line. Well, we can't do that anymore. And so with the factory the way it's set up now, I can do it literally overnight. So we got the call on Monday night. This is Monday night. The guy says, I need to double the production rate. We need it now. It's really important. So the team got together and we held a change board meeting. And the change board is not change board like we normally think of with the product. This is a change board of the configuration of the factory. The folks who work for me aren't allowed to change the configuration unless they bring it to the change board. The change board has 20 different checkpoints that they do on lean manufacturing, to make sure that we maintain the lean integrity that was built into the factory. And of course they checked them all off, and the change board approved it that night. It was Monday, then Tuesday night they stayed after work. And there's 7 guys here. There's 3 students, a couple of operators, and one of our industrial engineers. And what I told the team is, I want you to think like the NASCAR pit crew. Everyone's got a job, and I want you to see how fast you can do this. And we had the video in the factory for some training that we were doing. I said, okay, video it. I want to see how long it'll take. I kind of gave them a challenge. So what they did is and we videoed it, and what I want to show you is something that took 2 hours and 15 minutes to do. And they rearranged the core of the factory, and what I'll do now is play it. It takes 60 seconds to play, and you get an idea of what can be done with this flexible system. Ready to go? I wish they could move this fast in real life. So they're reconfiguring the entire night side line here. And when they've reconfigured it, they added additional stations so that we've got this set up so that now we've got twice the number of assembly stations for that. And we had to adjust some of the other areas to make up the difference. And it took 2 hours. Like I said, the elapsed time was 2 hours and 15 minutes. And the result is we've got a supermarket in the center with all the equipment that they need for that specific week of production. And then all on the outside, all of the work centers are set up to do a specific job. One of the subtle things that we've done is we did away with all the toolboxes. There are no more toolboxes that are owned by the operators. The toolboxes are owned by that work cell. And the tools in the work cell are only the tools called out by the manufacturing plant. The other subtle difference is that instead of bringing work to the operator, we now bring the operator to the work. So we've done cross-training across all the members of the cell so that the cell team can do any of the work that's done in the cell. So what that will do is the operator will do a job until there's a cure time. They don't go over here to the next work bench within that cell and do another job until there's an inspection call point. They don't go over here and do another part of the job until there is a test call out. By that time, the cure time is up, and he's always adding cost across his production line. So within that cell, there may be 15 different workstations, but there's only 4 operators in the whole cell. And that, we designed this choreography that goes from place to place so that they're always adding value. And that has really helped us reduce our costs and be responsive to the customer within the marketplace.
And then at the same time, when we have all the stations set up for a job, there's also features of the station that are customizable to the operator so that we don't ignore those very important ergonomic concepts. Each of those stations can raise and lower. It takes about a minute. They can go from very high for a tall person to very short. All of our chairs fluctuate. We have footstools for operators to need them. All the monitors are on pivot things with the keyboard underneath. You can put them anywhere you need to. Anything, the lights can be moved up and down. Every single part of that workstation can be adjusted pretty quickly to suit whatever operator is going to be at that station. It was really beneficial when you have people, that was actually my cell that I used to work on, and you only have 4 people, and all of a sudden one person is out sick. So you've really got to have stations that are set up to go for the product that anyone can take advantage and use and fill in, otherwise you'll never make deliveries. So that is a really important feature that the people can move to the products, and at the same time those stations can adjust to the needs of those people.
Any questions about that process? Pretty impressive. So you doubled the output in the same floor space, correct?
Yeah, we reallocated floor space from another work cell, and that had it was probably a little over capacity. So what we did is maximize and optimize the workspace that needed the additional work cell.
Okay.
Just a little story that was, there's a 2-step process for this where you have to do an application. Step 1 is application. It's pretty much data driven, and so you have to go through all of your metrics. And a lot of times these metrics are different than what you normally measure. So you've got to try to really understand what they're asking for and collect the data. And then the second part of it is if you get down selected from the top 25 to the top 10, they come and visit your plant. And in this case, we had, it wasn't Joel, it was one of the other, Brad Tenney, that came to visit us. And the Friday before he showed up, we had some construction work going on in one of the closed cells. It was on the far right-hand area here, and there was a contractor up there, and he was doing some work, and he had one of these JLG scissors lift, and he backed up, and when he backed up, he hit a 10-inch water line and broke the 10-inch water line. So in a period of about the next 10 or so minutes, we dumped over 20,000 gallons of water into the factory. And where these guys are standing, it was an almost ankle deep. So quick like a bunny, we have an emergency response team. We put them in place. We got the water turned off. By the time, that happened about 10:30 in the morning. By the time I got to the factory at 11:30, it was a day off, by the way. We do this 980 thing where every other Friday is an off Friday. We had a handful of people in the factory just doing some minor overtime. By the time I got there, it was about 45 minutes later, we had 100 people on site, sucking up water with vacuums. The team that was there literally picked up and moved the entire factory to the one side. All the inventory, all the work in process got moved because there wasn't a lot of work in process. I didn't have to worry about moving a lot. And then all the workstations got picked up and moved. And by Monday morning, when the folks came in, we not only had that, we had one of our customers coming in the same day. So we had, by Monday morning, you couldn't tell that anything had happened at all. We had people in there that had to dry out drywall, a special water abatement team. So the whole other side of the team, facilities team that has this emergency preparedness team, went into action, took care of that, and we were up and operating Monday. Without the flexible factory that we have right now, we'd have been sunk. The only long-term effect was a lot of the connections that we have underground utilities here, and every 30 feet you have an access port. So all these trenches got filled And so there's data lines there that are for high-speed data lines. Every one of the operators has their own touch screen that's connected to a computer that's connected to the LAN, so the manufacturing process plans show up at each of the centers. This is one of the screens right here, but they're at each of the workstations, so that as the operator is going through step by step, they'll see the manufacturing process plan. And it's almost all visual these days. Bringing in images from Pro-E, bringing in real-time photos, bringing in video into the system. And so we've gotten away from a lot of the words, the old MPPs that used to look like the New York City telephone directory. We've gotten to visual-based instructions. And so the connections to those were starting to get corroded after about a month. And we noticed the bit rate. And so we replaced them when we had a Christmas shutdown. And that was the only negative impact that we had.
All right, we don't have a whole lot more time. There are a couple areas I think are very unique about this facility. I'd like to cover, to make sure we cover, is if you could talk a little bit about your leadership development program. We kind of touched on that in the beginning, and how that is preparing the organization as a whole, not just this facility, for the future, as well as how it's influencing the culture as well.
Right. I'm in the Operations Leadership Development Program, but we also have it for engineering, LDP, human resources, finance, communications, and it's throughout the corporation. And
so every function has its own leadership program?
Just about every function. And then operations would be prod ops, quality, procurement, are all within that group, and the engineering one is more towards the design parts. But what that allows us to do is to go out and recruit hopefully the best and the brightest. It also allows us to develop new employees from within the company, which is what I was, and it gives us in 2 years, I have to go to a production prod ops environment role, a quality role, a procurement buying role, and then a fourth rotation that I can pick whatever role I want to go into. So I get a very large overview of the company in a very short amount of time, where I worked in this same quality role for 2 years, had no idea what any of these other people had to do in their jobs. So it really kind of builds an appreciation. It also helps build relationships throughout the company, so that we have people early on in their career that have contacts with all these different departments, so that we can work smoother together as a unit. And it's actually one of the cultural things that we picked up from one of the companies when we merged, and we kind of brought it into ours and made it our own. And it's expanding throughout our corporation.
The leadership also happens just at the early career level, but then throughout the levels of leadership, there are training that occurs across the board. Annually, we have a center in Bethesda that does leadership training there, and it's a week-long thing, and we bring in the speakers from all of the United States, plus our own homegrown group, and that helps with leadership development. We move people from place to place. We try not to get people stale, so that we can really have people that understand the entire business. The business is so varied that it's hard to, if you're here in Orlando, to understand the fire control portion of the business, to go to Owego and understand their business, or to space systems. So we'll move people around and really try to help them understand the whole business a little better. If you think about what's happening with folks my age, within 10 years of retirement, and there's bunches of us, we have to have a strategy and program in place to be able to continue the business. It's an intellectual, capital-driven business. It's all about providing the best technologies to our customers so that they can be successful, as I said, in their defining moments. So it's very, very important for us to get the right talent in at the right place, and the OLDP program is one of those ways that we're doing it.
Do you have a question back there?
Yes, I had a question regarding the you're pretty much on the cutting edge of technologies for both your products and I suspect therefore for a lot of the equipment that you use. Have you found over the last 5 to 10 years there's been some significant changes as far as your reliability strategy or your capital equipment life cycle strategy that you have implemented in order to adjust to this?
We've, every piece of capital that comes in, we do a formalized preventative maintenance program. We put that in place. We work with the supplier of the equipment to really understand what their life cycle is and what the maintenance actions have to occur. The whole factory, for example, is clean room, and so there are a fairly significant number of HEPA filters in the whole place, and they're variable belt drives that vary it to keep the whole factory at a positive pressure. Is one example I'll use. And we set up an entire whole preventative maintenance system to be able to keep that in place and working correctly. In fact, there are 47 different zones within the factory that would control temperature and humidity within our operating specifications. So we had to do that. On machine tools, we've had to do the same thing in our machine operating centers and OCC. So we've had to step it up because, as you said, a lot of the equipment, state-of-the-art equipment, it won't remain state-of-the-art equipment if you don't maintain it and keep on top of it. And it's something that our maintenance team has stepped up and done a very nice job with. It's helped us, in fact, in one of the metrics that we did very well. We do comparisons here. Once you get this, you can then see how you did relative to all the other people who have applied. So it's one of the things that if we look at all our competition that we're doing very, very well in because of the uptime.
The part of the question had to do with the fact that the life cycle of equipment has reduced, and when you're dealing with equipment that is very at the cutting edge, the equipment you're using will have a much shorter lifetime. As a result, your strategic planning for capital equipment has certainly changed dramatically. From it used to be you'd buy a CNC machine tool and keep it for 10, 20 years.
Right.
That has gone from 10 years to 5 years, sometimes driven by financing issues of 3 years. But your issue seems to be more one of the technological issues, and the technological obsolescence. How has that impacted both the reliability programs you're putting in place, how people are able to get up to speed to have a effective reliability program because of the technology changes, and then how has that impacted your life cycle analysis in purchasing and obsoleting capital equipment?
We actually have an IRAD program that is just not for product, but then for process as well. So we have an advanced technology manufacturing group that we fund every year to develop these emerging technologies. And in fact, as you said, a machine tool may have been 20 years in life in a lot of cases. And now because, let's just say, the precision of the systems have to continue to grow so that the standoff ranges continue to grow because our customer is expecting that kind of precision. Certainly we've seen those shorten. As far as once you have the product in place and you want to maintain it, we've done things like onboard metrology to be able to then not only measure how the machine is operating, but then to also measure what's happening with the product as it's coming off the machine. And so we've collect that data on an SPC basis and understand when the machine is getting to the point where it's not able to stay within the CPK that we expect. So I say one of the things that we probably have done different is the onboard metrology and the collecting of that data in an SPC database that we then take a look at.
All right, very good. I want to say thank you again, and congratulations again for winning the Best Plants Award, and thank you, Mel and Matt, for sharing your time today.